Today we're just gonna make kind of yes, Judy, you want to ask about something?
لا sorry. I raised my hand so.
Okay, so today we're gonna just make kind of this section review to revise, okay, to check the most important definitions and the ideas of the lesson. So let's start here. If you know the answer, just raise your hand, guys. So here, first question: define polar molecule in your own
Page
words.
what?
So that's page just a minute. 406. No, just 468. Okay. So here, guys, let's start. First question he asked: define polar molecule in your own words. What is a polar molecule, guys? Yes, Ali.
It's a molecule with a slightly negative end and positive end.
Good. So it's a molecule that has a slightly positive end and a slightly negative end. That's a good words. Okay, very good definition. Or in another word, we can say it's the molecule which have a slightly negative charge or slightly positive charge. It's okay. Or the molecule that has unequal distribution of charge. All these are true words. Okay. So the definition which Ali said is very good definition. So just let's write this definition together here. Okay. So we said that it is the molecule that has one slightly negative end and one slightly positive end. Okay, so that's the first question. Okay, that's so then here, just sorry. Let's just change this to be clear. So just put the answer. Okay, let's pass to the next one. Okay, the next question. What do you think? Okay, so here ask you explain how could you use solubility to a substance to make a saturated solution. If you know the solubility of a substance, could it be useful for you to make a saturated solution? Okay, Fadia. Can you hear me, guys? Fadia?
Yes.
Yep. So how solubility could help you to make a saturated solution? Yes.
Oh, okay. We add so much until the solvent is you had enough.
Yep. Okay. But how the solubility could help you in something like that? That's mean here he asks you if you know the solubility. First, we need to remember what is solubility. What the definition of solubility, guys? Anyone can remind me?
Is the maximum amount of solute that can dissolve in a given
Good. It's the maximum amount of solute that could dissolve in a given amount of solvent. So regarding to this, if you know the maximum amount of that solute that could dissolve in certain amount of solvent, so you could make a saturated solution. So we said that we said the solubility of substance help to make saturated solution because saturated solution, that solution which contain amount of solute equal the solubility of that solute. You get idea?
Yes.
Yeah, so we said we can make a saturated solution by dissolving the solubility of that solute. That means the maximum amount that this solution could carry or that could dissolve. Do you get the idea, guys?
Mister,
Yep.
I can't understand the saturated solution.
Look with me carefully. The saturated solution. So saturated solution, we said that the solution which is already the spaces between the particles of the solvent are completely filled by the solute. There is no more space for extra solute to be dissolved in. As we said, once you add spoons of salt to cup of water, so the first spoon dissolves, second spoon dissolves, but actually once you add the third or the fourth spoon, you may find that the salt cannot dissolve any more and settle down at the bottom of the cup. So why? Because actually the spaces between the water particles are completely filled by sodium chloride or the sodium ion and chlorine ion, and there is no more space for extra salt to be dissolved. In that case, we describe this solution as saturated solution. It's completely filled. You get the idea?
Yes, thank you, Miss.
So in that case here, he asks you if you know the solubility. For example, if we know that the solubility of sodium chloride, for example, is 30 grams for each 100 gram of water or each 100 milli of water. So simply like this, I know how to make a saturated solution of water. Simply get 100 milli of water and add 30 grams of sodium chloride. That is a saturated solution of sodium chloride. You got the idea, guys?
Yes, Mr.
Anyone cannot understand the question number 2? Don't skip any question that you cannot understand. Please, if you don't understand, just ask.
I
Thank
don't
you.
understand.
Okay. So let's pass to question number 3. He asked you predict.
Mr.
Yes.
Mr. Maya is telling you that her internet is slow, so she cannot enter. يعني she enters and يعني بتدخل
Okay.
بتطلع تاني.
No problem. Okay. So then pass to question 3. Predict whether an ionic compound will dissolve in a non-polar solvent or not. What do you think, guys? Yes, Reem?
It will not dissolve because ionic compounds are a polar substance,
Good.
so it's not soluble for non-polar substance.
Okay, good. So of course it will not dissolve because as we know, likes dissolve likes. Okay, that means the polar substances must dissolve in polar solvents, while non-polar solids must dissolve in non-polar solvents. So in that case here, ionic compounds, of course, a polar substance that must dissolve in a polar solvent. So it will not be able to dissolve in non-polar solvent. Is it clear, guys?
Yes.
Okay.
Yes.
So then let's pass to question number 4. Okay. In question number 4 here, he asked you use that graph, okay, to determine what would observe in a solution of 30 grams of potassium chlorate and 100 grams of water at 10 degrees Celsius. Okay. So here we find at 10 degrees Celsius, okay, so how much of potassium chloride, okay, that's the 10 degree here approximately. So how much 30 gram. So what's your observation, guys? That's the observation. We get 30 gram of potassium chloride and 100 gram of water, okay, at 10 degrees Celsius. What could you observe? Okay, guys, what do you think? We have 30 gram
Mr. I
at 10
can't
degrees.
understand what's in the graph.
You cannot understand the graph. Okay, so look with me carefully here, guys. This graph represents the relation between the temperature here, and that's the amount of solute. So it represents the amount of solute in grams for each 100 gram of water. So in the question, he asks you, use the graph to determine what do you observe. What's your observation in a solution of 30 gram? So solution that means 30 gram, okay, and at 10 degrees Celsius. So 30 gram at 10 degrees Celsius, what does it mean here? What do you observe? So
Mr. Can I try?
yes.
Okay. Not soluble, يعني it will not dissolve خالص.
Yeah, good. No, we said it will not dissolve absolutely, or little amount will dissolve.
Partially, yeah.
Yes, little amount. So we said that actually just little amount or few grams of these 30 gram will dissolve at 10 degrees Celsius. By increasing temperature, the 30 gram will keep dissolving. You get the idea? That means the 30 gram will be completely dissolved at 70 degree. You get the idea?
Yes. Okay.
You get this? Is it clear?
Yes.
Yes. So our observation here that the 30 gram of potassium chlorate does not dissolve completely, just a few grams dissolve it at 10 degrees Celsius, while the solubility increases, okay, as temperature increases, and the entire 30 grams will dissolve at 70 degrees Celsius. Is it clear here, guys?
Yes.
Any hard question?
No.
Are you sure, everyone?
Yes, Mr. Sur.
Yes.
Okay. So then let's pass to question number 5. He asks you just to make a kind of mind map. So copy the graphic organizer and use the organizer 3 factors that increase the speed of solute dissolves in liquid. If we need to speed up the solute process or dissolving process, what we should do? What do you think? Who can tell me? Let's find new people here, guys. Yes, Osama, could you tell us?
Yes.
Yep,
Uh,
just
key
one.
factors are temperature,
So increasing temperature. So here we said that increasing temperature. That the first one. Okay, good. What else?
Mister, can I say one?
Yes, Kenzie.
Increasing the volume of solvent.
Increasing the volume of solvent. Okay, that's good, sir, to be good. But there is another thing. Okay, so here, what do you think? So what?
Can I say one?
Yep.
Crushing the solid.
So crushing the solid. So good. Okay, so increasing the surface area or crushing the solid. So crush solute. Okay, so like this you increase the surface area, so it will dissolve faster. Increasing solvents at skins, it's considered to be okay. What else? One important. Yes.
Mr. May I answer?
Yep, Hannah.
Steering.
Steering, good. Okay, so just steer it. Okay, so all these are factors that could speed up the solubility process, of course. Okay, so thank you guys for your good answers. Let's pass to the next question. So here in question number 6, he said a student wants to increase the maximum amount of sugar that can dissolve in water. She crushes the sugar and then stirs it into the water. Does it work? What do you think, guys? So we need new people to answer. Yes, Nano, could you help us here? Does it work or not?
No, because the
Yes.
amount of water has certain solubility measures. يعني.
Good. Okay, so actually crushing the solute or stirring it, it will increase the solubility, but finally the water has
The speed, not
speed,
the
good.
maximum amount.
Not the amount, good. So here that will affect the speed, make it happen faster, but actually the maximum amount that the water could hold of that solute or the maximum capacity of water for that solute or the solubility of the solute is constant. It will never change. So in that case, this process actually will not work. So who can tell me what is the procedure that that student could do to increase the amount of solute that could dissolve?
Add the water.
No, we're still talking about the same amount of water.
Okay.
So adding water is okay.
Increase the temperature.
Excellent. Increasing temperature. In that case, it will turn from saturated to super saturated solution. Do you remember this, guys?
Yes.
Yep. So here like this, okay. Anyone
But
can
I
look
have
at?
a question.
Yep, of course, Hanan.
How when it becomes super saturated,
Yep.
when it cools down bad, the rest
Yes,
of the
yes, the extra amount of solute that dissolved will settle down again. It will recrystallize and fall down at the bottom of the cup one more time.
Okay. Nice.
Okay. Thank you. So here, guys, anyone cannot understand the question number 6? It's very important. Anyone cannot understand it?
No, thank you.
Clear for everyone?
Yes.
Very sure,
Yes.
guys?
Yes.
Okay. So let's pass to question number 7 here. Use the ratios to explain how a tablespoon of soap and a cup of the same and the cup of the same soup have the same concentration. That's very good. Okay. Anyone able to answer this question? Have an idea how we can make this?
Mr. Can I try?
Yes, of course.
Okay. They have the same concentration.
Yeah.
Because the mass and volume of the soap remains constant.
Good.
Relative.
Good. Because actually concentration, it represents the ratio or represent the relation between the mass of the solute over the volume of the solvent. So in that case, whatever as you, for example, in let's try to do it in numbers to make it clear for everyone. So for example, if we have a cup of water, this cup of water about 200 milli or 0. Let's make it in liter, 0.2 liter of water, okay? And we dissolve about 10 grams of solid in. So in that case, concentration will equal 10 divided by 0.2, that equals how much? Anyone know?
50.
That's equal 50, good. So that's equal 50 gram per liter. That's good. Here, that's the concentration in the cup for. Imagine that we just pick 1 spoon of that solution, okay? So this spoon, for example, is gonna be, for example, the volume will be about 0.02 liter, okay? And in that situation, we're gonna find here that the amount with 1 gram dissolved in. So like this, the concentration will be also 50. So it's still the same concentration, guys. You got the idea?
Yes.
Sorry. So it's still the same concentration, no change. So in that case here, we find that concentration, just a relation between mass over volume. So the mass of the substance dissolved and the volume will be never change. So they still have the same concentration. So any hard question regarding to this part, guys?
No.
So
No, thank you.
anything is not clear?
No, Mr. Thank
No,
you.
thank you.
Okay, so please check your SMS to find the weekly plan, okay, to know the material that will be covered in your next quiz and to know what we're going to do next week. And as we said, guys, remember that we have 10% of questions in exam of quarter 3 covering material of quarter 2. So we're going to start to revise material of quarter 2 next week. So try to just fresh your mind, okay, remember what the topics which we're talking about in quarter 2, the minerals, their properties, the rocks, and so on, and to be able to answer the question during the revision. So, any question here, guys?
Mr.
Yes, Judy.
When is the exam?
The exam will be after 3 weeks. Okay, it will be in the beginning of April. I think it will be in 4th of April. So, in the beginning of April, that means just 3 weeks, okay, left before we start the exam. So we need just to wrap up everything, okay? So any hard question regarding to what we explained, guys?
Can I ask a question?
Yes, of course, Kenzie.
Mister will take all the topics that we take it in terms of, or few, or what?
Okay, so here, listen, Kenzie. Regarding to this